Hello, children. Welcome to Right Tuition Classes. Before going ahead with the theorems of the circle chapter, let us try to understand these three terms. Inscribed angle. What do you mean by inscribed angle? What do you mean by intercepted arc? And what do you mean by an arc inscribing an angle? Okay. So let us try to understand what do you mean by an inscribed angle first. So look here, children. In this diagram, I'm just trying to show you a circle here. Now look at this angle, children. This angle has its, just have a look at this angle, children. Okay? And what we realize is this angle has its vertex on the circle, children. I'm so sorry. This vertex is on the circle, okay? And its two sides. Can you see the two sides? Side B and side BC. They again intersect the circle. So such an angle is called an inscribed angle. Angle जिसका वर्टेक्स सर्कल के ऊपर है और उनके दोनों साइड्स फिर से सर्कल को इंटरसेक्ट कर रहा है, ऐसे एंगल को inscribed angle बोलते हैं. Are you getting me here? Like you cannot call. Please have a look at this. Okay, I cannot call your this vertex is on the circle. Okay, this. Oh, so sorry. So sorry. I'm just so sorry about it. Okay, I did a mistake. Okay, just have a look here. This angle, okay, the vertex no doubt lies on the circle. And look at this side, okay, this side, it intersects the circle at one point, but the other side is not again intersecting the circle. So such an angle, I cannot call it an inscribed angle, children. So what, once again, I'll show you another option, okay? If you look at this, children, this circle here in this figure, okay, in this figure, you can see, children, the angle, the vertex of the angle lies outside the circle. Vertex of the angle lies outside the circle, and its two sides, intersect the circle once again. But this angle is again not an inscribed angle. So किसको inscribed angle बोलते हैं बेटा? Angle जिसका vertex circle के ऊपर हो and its two sides are again intersecting the circle. Vertex जिसका circle के ऊपर हो and its two sides are again intersecting the circle. Such an angle is called an inscribed angle. I hope people are getting me here. Now, what do you mean by an intercepted arc? The intercepted arc, जो दोनों sides, let the sides circle be anyhow. Let the angle be anyhow, children. Got it? But if the vertex of the angle lies on the circle and its two sides intersect the circle, no doubt this is an inscribed angle. But you can look at this arc, children. You can look at this arc, okay? Look at this arc. This arc is a red color arc, but don't you agree it is between the two sides? Such an arc which gets stranded between the two sides, we call it as an intercepted arc. We call it as an intercepted arc. We call it as an intercepted arc, okay? Like, again, I can show you, children, one more. Yeah, you can see it here, children. Like this circle, okay? I got a red circle, okay? Now this circle, the sides are, please have a look here. The sides are intersecting the circle. Okay, here, this side, like, this side, okay? Vertex lies are on the circle, but this is not an inscribed angle. This is not an inscribed angle, children. You can see here, this is not an inscribed angle. This is not an inscribed angle. But what happens, children? Look at this arc, children. One endpoint lies on one of the sides. The other endpoint is a vertex. I can say it lies on the other side. So such an arc whose one endpoint lies on one of the sides and the other endpoint lies on the other side, we call that arc as an intercepted arc. We call it an intercepted arc. So here, this arc is an intercepted arc. This arc is an intercepted arc. This arc is an intercepted arc. Are you getting me, children? This arc is an intercepted arc. Now you can see here, children, some more examples I'll just show you, okay? Like, suppose here, just have a look at this arcs, okay? Here, this angle, vertex lies outside the circle, no problem at all. But this angle has two intercepted arcs. This angle has, but this arc is also intercepted between the two sides, stranded between the two sides. I'll show it to you. This red color arc is stranded between the two sides. intercepted arc. This red color arc is again standard between the two sides. So this angle is having two different intercepted arcs. Okay, but a simple intercepted arc किसको बोलते हैं? जो आर्क दोनों साइड्स के बीच में फंस जाता है, वो एंगल कैसे भी रहने देना. Okay, let the angle be anyhow, children. Let the angle be anyhow, right? You can see here. Okay, this angle, children, please have a look at this. Okay, this angle, okay? Look at this angle, children. This is neither a central angle nor an inscapped angle, but just an angle, okay? It has an intercepted arc. This is an intercepted arc. This is an intercepted arc. This I'm shading it, okay? Blue, black, okay? This arc is an intercepted arc. Are you getting me, children? Then you can have a central angle, children. The central angle, suppose O is a central circle. This central angle, children, this arc is called an intercepted arc. The arc is called an intercepted arc. This arc is called an intercepted arc. बेसिकली दोनों साइड के बीच में जो आर्क फंस जाता है उसको इंटरसेप्टेड आर्क बोलते हैं. Now look at, children, the next one. Okay, I'll just show you. Okay, just have a look at this. I'm just drawing all types of inscribed angles. Okay, you can see here, children, this is an inscribed angle. Its vertex lies on the circle and the two sides are intersecting the circle. Okay, this is an inscribed angle. Vertex lies on the circle and the two sides are intersecting the circle. This is an inscribed angle, children. Vertex lies on the circle and the two sides are again intersecting the circle. This is an inscribed angle, children. Vertex lies on the circle and the two sides are inscribing. So all the circles have an intercepted arc. Intercepted arc जो दोनों sides के बीच में फंस गया है. Now, when you ask me what are the intercepted arcs, you can see here, children, which are the intercepted arcs. You can easily come to know which are the intercepted arcs, children. Like, I'll just show it to you, children. Like here, this is an intercepted arc. The red color is an intercepted arc. I should say the red color arc is an intercepted arc. 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 But here, the heading was, children, heading was what is, and please have a look here, which is an arc inscribing the angle. The heading is, which is an arc inscribing the angle. Just have a look at this, children. I'll just show you. Look at this blue color arc. The arc contains a vertex of the inscribed angle. Got it? And also it contains these 2 points of the sides. Are you getting me here? Of the inscribed angle. This arc is containing the inscribed angle. That arc, we call it as arc inscribing an angle. Look at this arc element. This blue color arc is containing the vertex of the inscribed angle. And also it contains the 2 points where the sides intersect the circle. So this arc, blue arc, is an arc intercept inscribing the angle. This blue color arc is an arc inscribing an angle. This blue color arc is the arc inscribing an angle. The arc containing the inscribed angle is called arc inscribing an angle. The arc containing the inscribed angle is called an arc inscribing an angle. Arc containing the inscribed angle is called an arc inscribing the angle. So remember, children, Paila, what did I say was about an inscribed angle? Okay, children. Then I told you intercepted arc. जो arc दोनों sides के बीच में फंस गया उसको intercepted arc बोलते हैं. Then arc containing the inscribed angle. These blue arcs are arcs containing the inscribed angle. These arcs are arcs inscribing an angle. Okay. So I just try to tell you in short all these three, children. Let's go ahead. Now we go to something very important, children. So this angle ABC is an inscribed angle. The vertex B lies on the circle and the two sides intersect the circle. Such an angle is called an inscribed angle. So angle ABC is an inscribed angle. Angle ABC is an inscribed angle, okay? And when you look at it, children, when you look at this, children, this arc is an intercepted arc. This arc AC is the intercepted arc. Arc AC is the intercepted arc. Angle ABC is an inscribed angle and arc AC is an inscribed angle. Okay, intercepted arc. Angle ABC is an inscribed angle. Arc AC is a intercepted arc. So the moment you see this, children, you see an inscribed angle and you see an intercepted arc of it. So immediately, like a formula, it should come to your mind. Angle ABC is always equal to half measure of AC. Angle ABC equal half measure of AC. Angle ABC equal half measure of AC. Again, children, look at this angle element, okay? This element is an inscribed angle. This element is an inscribed angle. This element is an inscribed angle. And don't agree, arc ln is an intercepted arc. Arc ln is an intercepted arc. So naturally, what should come to your mind, children? Angle element is equal to L. Sorry, I'm so sorry here. Okay, angle element angle element angle element is equal to half measure of arc ln. So the moment you see an inscribed angle, this property should come to mind. Measure of an inscribed angle is half the intercepted arc. Right. Suppose this triangle is XYZ. Okay. Don't agree it's an inscribed angle. The moment you see an inscribed angle, measure of an inscribed angle equal half the measure of its intercepted arc, which is the intercepted arc for its children xz. दोनों sides के बीच में जो फंस गया है xz. Are you getting me? Suppose this is your inscribed angle PQR, okay, which is the intercepted arc of it PR. So what should come to your mind? Angle PQR equal half measure of PR, like a formula. So the moment you see an inscribed angle in this chapter, circle arc, it should come to your mind this statement. The measure of an inscribed angle is measure of an inscribed angle is measure of an inscribed angle is half the angle is half the measure of its intercepted arc. Half the measure of its intercepted arc. Half the measure of its intercepted arc. The moment you look, please keep in your mind, children. The moment you see an inscribed angle, measure of an inscribed angle is half the measure of its intercepted arc. So everywhere you can see angle ABC was the inscribed angle, AC was the intercepted arc. So क्या formula है? ABC equal half measure arc AC. Angle LMN is an inscribed angle, LN is the intercepted arc. So what is the formula? Angle LMN equal half measure arc LN. Angle XYZ is an inscribed angle, XZ is the intercepted arc. So angle XYZ equal half measure arc XZ. Angle PQR is an inscribed angle, PR is the intercepted arc. So PQR equal half measure arc PR. So remember this statement, measure of an inscribed angle is half the measure of its intercepted arc. Measure of an inscribed angle is half the measure of its intercepted arc. The proof of this theorem, which is discussed in 3 cases. Again, I don't think for last 20 years it has never been asked. It should be asked. Are you getting me, children? We go ahead to our next question. Next, corollary of this theorems. Corollaries are nothing but property derived from this theorem. Properties derived from this theorem. So many corollaries you're going to learn now, children, one at a time. Theorem says, in a new theorem, children, angle inscribed in a semicircle is a right angle. Angle inscribed in a semicircle is a right angle. Prove that. I mean, okay, like a theorem, angle inscribed in a semicircle is a right angle. Now, what does it mean, children? Like, suppose this is a circle, okay? And whenever you see a diameter of a circle, children, the diameter tells you the semicircle. Suppose AB is a diameter, AB is a diameter, okay? AB is a diameter, okay, children? This AB is a diameter. If AB is a diameter, children, then these two arcs above the diameter and below the diameter are semicircles. We can call it a semicircular arcs. Okay. Now you can see here, children. So this is any one angle I show you. This angle, you can see here, children, its vertex lies on the circle. And its two sides intersect the circle. The two sides intersect the diameter at the endpoints. Are you getting me here? It's an inscribed angle. It's an inscribed angle. And the two sides again intersect the diameter at the endpoints. Such an angle, we call it as an angle inscribed in a semicircle. You can see here the arc containing it. The arc containing it. Let me show you like this, children. The arc containing it is and the arc which is containing it. This arc which is containing it. This arc which is containing it. You can see here, children, this arc which is containing it. The pink color arc which is is a semicircle. So this is an angle inscribed in a semicircle. This is an angle inscribed in a semicircle. Okay. So this is angle, suppose angle ACB. This angle is inscribed in a semicircle. The moment you see an angle is inscribed in a semicircle, it should come to your mind. Angle ACB equal 90 degrees. Angle ACB equal, the angle inscribed in a semicircle is a right angle. Angle inscribed in a semicircle is a right angle. Are you getting me, children? Okay. Now how this question is asked in your exam. How this question is asked in your exam. How like this theorem is asked in exam. Prove that the angle inscribed in a semicircle is a right angle. This is the way it is asked in your exam, children. Prove that angle inscribed in a semicircle is a right angle. Always remember, children, I told you, children, when a question comes in this writer form, you have to draw the diagram, you have to write given, you have to write prove that, you have to write proof. कैसा करेंगे? Please have a look here. I told you something very simple, children, very simple idea I've given you. Whenever you can see this word is or are, is का पहला जो दिख रहा है बेटा, is का पहला जो दिख रहा है आपको, ओके उसमें आपको गिवन वो डायग्राम ड्रॉ करने में मदद करता है. एंगल इंस्क्राइब्ड इन अ सेमी सर्कल, तो ये मदद कर रहा है. ओके so this diagram I'm going to draw a circle. Okay, I'm going to draw a circle. After drawing a circle, I'm going to draw a diameter. Why a diameter is needed? Because diameter helps you to identify the semicircle. Diameter helps you to identify a semicircle. If they say AB is a diameter, then confirmed upper semicircle and niche semicircle. Okay. Then angle inscribed in a semicircle. So I'll draw an angle inscribed in a semicircle. Anyhow, it should be, but only thing it should be an inscribed angle. And the endpoints of the other side should intersect the diameter at the endpoints. You can see here, this is an angle inscribed in a semicircle. This is an angle inscribed in a semicircle. I'll call this as C. I'll call this as C. Okay. So look here, children. What am I going to do now? Angle in this, I'm going to take it as C, properly C. Okay. This is my C. So what given? After drawing the diagram, I'm going to write given, okay? First, I'll mention segment AB is the diameter of circle, okay? Now listen, you'll say, what is the use of diameter? And it just helps you to understand this two are semicircles. These two are semicircles. ACB and AXB are semicircles. And now I'll write angle ACB is inscribed in a semicircle. Angle ACB is inscribed in a semicircle. Got it? Angle ACB is inscribed in a semicircle ACB. Got it? Prove that. Please have a look here. This angle inscribed in a semicircle is a right angle. So this angle ACB equal 90 degrees. ACB equal 90 degrees. I think I better prefer dark little, okay? So the proof, children, you can see here, children. Got it? Now, whenever you see an inscribed angle, I told you, children, think of inscribed angle theorem. So angle ACB is an inscribed angle. So angle ACB equal half measure of arc AXB. I told you, children, measure of an inscribed angle is half the measure of its intercepted arc. So angle ACB is half arc AXB. Reason, I call this as 1 by inscribed angle theorem, by inscribed angle theorem, by inscribed angle theorem, by inscribed angle theorem. But measure arc AXB, just have a look at it. But measure arc AXB is equal to 180 degrees, children. Measure arc AXB equal 180 degrees. What's the reason, children? Measure of a semicircle. Measure of a semicircle. Measure of a semicircle. Measure of a semicircle. Measure of semicircle. Okay. Therefore, angle ACB equal, children, what will happen? Half into 180. Half into 180. Can I say, children? I call this as theta number 2. This is 1. So can I say the reason is from 1 and 2? From 1 and 2. Okay. So now what will happen? Two ones are 290s. The angle ACB equal 90 degree. Please write the statement. Therefore, in every theorem, whenever you prove a theorem, okay, you will not write this question. You will draw the picture, you write given, prove that proof. So rewrite the statement in the end. Therefore, angle inscribed, okay, in a semicircle is a right angle, angle inscribed in the semicircle is a right angle. I hope everybody got me here. Very simple, very easy. Okay, we move on to the next theorem, children. Now very easy theorem. All these theorems are going to learn, they are very simple. Theorem, children. Another theorem. Angles inscribed, plural word, angles inscribed in the same arc are congruent. You can see here, children, there is an inscribed angle here, and this angle ABC, suppose this angle ABC. This angle, if I name it as ABC, children, this angle, if I name it as A, B, C, this is an inscribed angle. Its vertex lies on the circle. Two sides intersect the circle, inscribed angle. Again, children, look at this angle ADC. Vertex lies on the circle. Two sides intersect the circle. It's an inscribed angle. But when you look at both these inscribed angles, they are inscribed, okay? They are contained. I better say contained. Don't you agree in the same arc? Suppose this arc AB. I just color this arc. Look, angle ABC is inscribed in this green arc. Even angle ADC is inscribed in the green arc. In other words, angle ABC is contained in this green arc. Angle ADC is also contained in the same arc. Or I'll more simplify, children. Remember one thing, children. These are angles inscribed in the same arc. These are angles inscribed in the same arc. Like angle ABC is inscribed in arc ABC. Angle ADC is inscribed in arc ADC. But arc ABC, arc ADC, they are different names of the same arc. That means these are angles inscribed in the same arc. These angles inscribed in the same arc are always, the moment you see these angles inscribed in the same arc, you can always say angle ABC congruent angle ADC. Like let's see another example. Suppose this is your angle PQR. Just have a look at this angle PQR. Okay, PQR. It is intercepted. It is, you can see here, children, it is contained in the same arc. Angle PQR is inscribed in this arc PQR. And this angle, please have a look at the other angle, children. This angle is also contained in this angle PSR is also contained in the same yellow arc. Angle PQR and angle PSR both are inscribed angles, inscribed in the same arc. They're contained in the same arc. They're inscribed in the same arc. So angle PQR, you can always say, is congruent to angle PSR, angles inscribed in the same arc. One more example, children. Suppose this is your angle XYZ. You can see vertex lies on the circle, two sides intersect the circle, inscribed angle. It is inscribed in which arc? Arc XYZ. Look at this angle XMZ. Vertex on the circle, two sides intersect the circle. So naturally inscribed, it is inscribed in which arc? Arc XMZ. Arc XYZ and arc XMZ. Don't we agree, children? They are names of the same arc. They are names of the same arc. Children, you can see here, they are names of the same arc. You can see here it starts from X. Can you see this light color of green, I think? It starts from X, goes up till Z. So these two angles are inscribed in the same arc. So you can always say, children, these angles are always congruent, okay? Angles inscribed in the same arc are congruent. Like angle XYZ. is congruent to angle XMZ. Are you getting me, children? So I hope as a theorem this is clear. But in your exam, they're going to ask you this to be proved. Okay, prove that. So how it is asked? Let's see here, children. How it is asked in your prove that angles, plural, do more than one. Okay, angles inscribed in the same arc are congruent. Matlab, there's a rider, children. I have to draw the diagram, I have to write given, I have to write prove that. The arc pehla jo hai, it helps you to draw the diagram. Angles inscribed in the same arc. So I can easily draw the diagram, children. Angles inscribed in the same arc. So I draw a circle. Got it? I'm going to draw two different angles inscribed in the same arc. Like suppose this is your angle ABC, okay? This angle ABC, it is inscribed in arc ABC. It is inscribed in arc ABC. Got it? Can you see it's an inscribed angle, inscribed in arc ABC. But angles, plural word, angles inscribed in the same arc. So look at this angle, children. This angle is also this angle is also angle inscribed in the same arc. Like you can see here, this angle I'll name it as angle ADC. Angle ADC is inscribed in arc ADC. Angle ABC is inscribed in arc ABC. Angle ADC is inscribed in arc ADC. But ABC and ADC are different names of the same arc. That means these two angles are inscribed in the same arc. So what is given, children, are drawn here. So I'm going to write angle ABC and angle ADC are inscribed in the same arc ABC. Okay, angle ABC and ADC are inscribed in the same arc ABC. Prove that angle ABC congruent angle ADC. Prove that angle ABC congruent angle ADC. So see the proof, children, how we go about such a simple one. This angle ABC is an inscribed angle, children, intercepting this arc. So what is this? I want this angle ABC. So I can use inscribed angle theorem. What is angle ABC equal, children? ABC equal half measure arc AC. Angle ABC equal half measure arc AC. I call this as 1, okay? And look at angle ADC, children. What is angle ADC equal? Half measure arc AC. Again, ADC is an inscribed angle, children, intercepting arc AC. ADC is also half arc AC. Statement number 2. The reason for both of them, inscribed angle theorem. Inscribed angle theorem. Inscribed angle theorem. Inscribed angle theorem. Now look at it. Right hand side same hai beta. So left hand side angle ABC is equal to angle ADC. Okay, from 1 and 2. From 1 and 2. So naturally, children, I can say therefore angle ABC congruent angle ADC. Angle ABC congruent angle ADC. Well, the angles inscribed in the same arc are congruent. Angles inscribed in the same arc are congruent. When all the four vertices of a quadrilateral lie on a circle, same circle, then the quadrilateral is called a cyclic quadrilateral. देखो एक quadrilateral ABCD है उसको चारों vertex A, B, C and D lie on the same circle. So naturally such a quadrilateral is called a cyclic quadrilateral. Remember all quadrilaterals need not be cyclic. मतलब जैसे एक triangle रहेगा, you know, a circle will always pass through all the three vertices of a triangle. But likewise, a circle need not pass through all the four vertices of a quadrilateral. It may pass, it may not pass. But if it passes through all the four vertices, we say the quadrilateral is cyclic quadrilateral. I hope it is clear. Now, what is a cyclic? This cyclic quadrilateral has a very important property. And what is that property, children? I will just call it as theorem of cyclic quadrilateral. See the property, what it says. Opposite angles of cyclic quadrilateral are supplementary. Means when we see a cyclic quadrilateral, children, when we see a cyclic quadrilateral, immediately it should come to your mind. Its opposite angles are supplementary. Its opposite angles are supplementary. Like you can see a cyclic quadrilateral here, children. I'm just trying to show you here. Okay. You can see a cyclic quadrilateral PQRS. You can see a cyclic quadrilateral PQRS here. So naturally, you can always say this angle QPS plus angle QRS equal 180. Opposite angles of cyclic quadrilateral are supplementary. Or you can take PQR, angle PQR plus angle PSR is equal to 180. So either you can say this way, opposite angles of cyclic quadrilateral are supplementary, or you can say it this way, children, opposite angles of cyclic quadrilateral are supplementary. Okay, children. But the moment you see a cyclic quadrilateral, this property should come to your mind. Okay, very simple sums they can ask. Are you getting me? Suppose this angle is 120 degree, QPS is 120 degree. What is angle QRS? So it should come to your mind. Quadrilateral PQRS is a cyclic quadrilateral. Therefore, angle QPS plus angle QRS equal 180. Opposite angles of cyclic quadrilateral are supplementary. 120 plus QRS equal 180. QRS equal 180 minus 120. QRS equal 60. Got it, children? This way, they can ask you simple questions. Well, in short, I'll say whenever you see a cyclic quadrilateral, it should come to your mind opposite angles are supplementary. Now, see here, children. Very, very, very important it is. It will come in your board exam to prove this theorem. The way it is asked in your board exam. Just here. In an exam, it will come like this. Prove that opposite angles of cyclic quadrilateral are supplementary. Prove that opposite angles of cyclic quadrilateral are supplementary. So remember, children, I always told you this is called a rider. तो इसका एक डायग्राम बनाने का मुझे फिगर बनाने का गिवन लिखना है तो मैंने हमेशा सिखाया कि आर का पहला जो है वो मदद करेगा आपको ड्रॉ करने में ऑपोजिट एंगल्स ऑफ साइक्लिक क्वाड्रेटल मतलब साइक्लिक क्वाड्रेटल ड्रॉ करने का उसमें ऑपोजिट एंगल्स तो होंगे ही so I want to draw a cyclic quadrilateral. I want to draw a cyclic quadrilateral. So I'll draw a cyclic quadrilateral, okay? And now listen here. I'll draw a cyclic quadrilateral. I told you, children. This quadrilateral is cyclic, okay? This quadrilateral is cyclic, okay, children? Now, any, please here. So I'll say this what I've drawn. I have to write a picture talk of it. It's called given information. What is that? What I've drawn is a cyclic quadrilateral. So I'll just write like this. Quadrilateral ABCD is a cyclic quadrilateral. Quadrilateral ABCD is a cyclic quadrilateral, children. And what do you want to prove, children? You want to prove that opposite angles are supplementary. Suppose I take angle ABC. This angle ABC plus angle ADC is equal to 180 degrees. Okay. ABC plus ADC equal 180 degrees. Okay. ABC and ADC. Or if I take this angle BAD and this BCD, angle BAD plus angle BCD equal 180. Opposite angles of cyclic quadrilateral are supplementary. Okay, they wanted to prove this. They wanted to prove this. Children, very simple proof. Very simple proof means very simple proof. Okay, once you are learned, you cannot forget. Okay, you cannot forget. It's enough. Okay, if you learn once. Now look here. Look at this angle ABC which you want first. When I look at this angle ABC, what I realized this angle ABC is an inscribed angle. This angle ABC is an inscribed angle, okay? And naturally, this ABC is an inscribed angle. And arc ADC is its intercepted arc. Arc ADC is a intercepted arc, okay? Arc ADC is a intercepted arc. So naturally, children, I can use inscribed angle theorem. Okay, I can use inscribed angle theorem. What is that? Angle ABC I want. Okay, angle ABC I want, children. This angle ABC, I want this angle ABC. Okay, so this angle ABC, when you want ABC, just have a look, is an inscribed angle, intercepting arc ADC. So angle ABC equal half measure arc ADC. What is the reason, children? I call this as statement number 1. And of course, it's inscribed angle theorem. But when I look at angle ADC, I'm not writing the reason immediately. Just have a look at angle ADC. Look at angle ADC. This angle ADC, when you look at it, children, again, children, you can see this angle ADC, okay, is an Again, inscribed angle. Intercepting which arc, children? Intercepting this yellow arc. Arc ABC. Arc ABC. So naturally, children, I'm going to use inscribed angle theorem. Okay, I'm going to use inscribed angle theorem. So what it will be, children? Measure of angle ADC equal half measure of arc ABC, the yellow arc ABC, children. I know, okay? This is statement number 2. For both of them, the reason is same, children, by inscribed angle theorem. By inscribed angle theorem, because both are inscribed angles. So naturally, I have to use inscribed angle theorem to get it. Now, I want ABC plus ADC. इनको add करके 180 दिखाना. So I'll add this 1 and 2. So when I add, the left-hand side gets added up, ABC plus ADC, okay? So naturally, the right-hand side will get added up, half common, I'll remove, and what will happen? Measure of arc ADC plus measure of arc ABC, children. Measure arc ABC, they get added up, okay? Reason is, I'll just write it down, adding. There's a reason for them adding 1 and 2. Now you can see, have you got your answer? No, you got ABC plus ADC, but you're not got 180. But look carefully, this arc ADC and arc ABC. The brown arc and the yellow arc, together they become circle. They become a circle, children. And what is measure of a circle? 360. So angle ABC plus angle ADC equal, what I can say, children? Half into 360 degree. And what reason you'll say? There's two halves. When you add, you got 360 because of R addition property. What is that? R addition property. That is, when two arcs of the same circle have both their endpoints common, na? Got it? Then sum of the two arcs, with both the endpoints you can see common here. So the sum of the two arcs is 360, okay? So angle ABC plus angle ADC, kitna aega beta? Half into 360, 180. I think I got my first answer. Angle ABC plus ADC equal 180. Okay? Similarly, children, similarly you can say, similarly we can prove, we can prove, remember, angle BAD plus angle BCD is equal to 180 degree. So now onwards, remember, children, opposite angles of cyclic quadrilateral are supplementary. Whenever you see a cyclic quadrilateral, remember, children, opposite angles are supplementary. Okay, we go to the next one, our next theorem, children. Cyclic quadrilateral. Children, any quadrilateral is given to you. Any quadrilateral is given to you. And they may ask, is this a cyclic quadrilateral? Is this a cyclic quadrilateral? So what? I cannot draw a circle and see. But remember, if you see the opposite angles are supplementary, if you happen to prove or if you happen to see that opposite angles, when you add them, ABC plus ADC equal 180, at once I can say ABCD is a cyclic quadrilateral. If opposite angles are supplementary, the quadrilateral is cyclic. So remember this property, children, in a very simple way I showed you. If opposite angles, I can call it as a test for cyclic quadrilateral. If opposite angles of a quadrilateral are supplementary, if opposite angles of a quadrilateral are supplementary, then the quadrilateral is cyclic. Then the quadrilateral is cyclic. याद रखो बेटा. If opposite angles of any quadrilateral are supplementary, like suppose if they ask you, prove that every rectangle is a cyclic quadrilateral. So I'll say, given quadrilateral ABCD is a rectangle. Given quadrilateral ABCD is a rectangle, okay? So just tell me now, what is any one pair of opposite angles we go? Angle B equal 90, angle of a rectangle, angle D equal 90, angle of a rectangle. अरे add कर दो, angle B plus angle D कितना होता है? 90 plus 90 कितना होता है? 180. And opposite angles are supplementary. Therefore, quadrilateral ABCD is cyclic. Hence, every rectangle we can show it is cyclic. Are you getting me? Every square in a similar way, every square is a cyclic quadrilateral. Every square is a cyclic quadrilateral, because even in squares, the opposite angles when you add, you're going to get 180. Got it? So remember, children, opposite angles of a quadrilateral are supplementary. The quadrilateral is called the cyclic quadrilateral. Now, one more property I'm going to tell you, students. This property, I've got no proof for it, okay? Just a property you should know, okay? That is the reason why I showed you. Now we are coming to one very, very important property, but no proof of it. But you have to understand it, okay? So remember, children, just have a look here, children. One thing I would like to tell you, like suppose there is one segment PQ, okay? Segment XY. Suppose this is your segment XY, okay? And from the endpoints of X and Y, segments are drawn to intersect at A. So I can always say this segment XY subtends SUBTNDS subtends angle A. Segment XY subtends angle A. Got it? Like suppose this is MN, okay? And from the endpoints of M and N, okay, segments are drawn to intersect at Q. So segment MN subtends angle MQN, okay? So I hope everybody's getting the idea of subtends, okay? Now I'm discussing one theorem. Just have a look at children. No proof for it, but you should know, okay? Like when a segment subtends congruent angles at two distinct points lying to the same side of it. Just have a look at this, children. Segment subtends, then a segment subtends congruent angles at two distinct points lying to the same side of it. Got it? You can see it here, children. In this, you can check it. Okay. Segment AB. Can you see the segment AB? Okay, from the endpoints of A and B, from the endpoints of the segment A and B, red segments are drawn to intersect at P. Angle ACB is formed. So segment AB subtends angle ACB. Again, from these endpoints of segment AB, green segments are drawn to intersect at P. So angle APB is formed. I can say segment AB subtends angle APB. Now, if these two angles both are equal, suppose this is 70 degree, this is 70 degree. So I can say segment AB subtends congruent angles at two distinct points lying to the same side of it. Both lie above AB. So we say they're lying to the same side of it. So segment AB subtends congruent angles at 2 points lying to the same side of it. If you see this condition, you can say then the 2 points, then the endpoints of the segment, that is A and B, and the 2 points are concyclic. Concyclic का मतलब क्या है? देखो, when the points lie on the same line, we call them as collinear points. When a point lies on the same circle, we call these points as concyclic points. So here, segment AB subtends congruent angles at two distinct points lying to the same side of it. The moment I say this condition, I can say points A, B, P, and C are concyclic, means they lie on the same circle. They lie on the same circle. They lie on the same circle. I hope people are understanding me here. When a segment like AB subtends, you can see a makes congruent angles at two distinct points lying to the same side of it. Then the endpoints of the segment and the 2 points are concyclic. Means they lie on a circle. They lie on a circle. I hope everybody understood this. Got it? Is this clear? The proof of it is never asked, okay? But if you know this statement, okay, children, we go ahead, children, to another theorem now. Try to understand. Let's have a look at this. Given an angle whose vertex lies outside the circle and its two sides intercept two different arcs of the same circle. Again, what I've written in red, try to read it. Given an angle whose vertex lies outside the circle and its two sides intercept two different arcs of the same circle. Given an angle whose vertex lies outside the circle and its two sides intercept two different arcs of the same circle. That means it should be like this, children. If you give a thought for it, you can understand this, okay? It should be like this. Suppose this is a circle, okay? And given an angle whose vertex lies outside the circle, like this is one angle. Just have a look at this, okay? Just have a look at this angle, okay, children? This angle, you can see angle ABC, okay? Angle ABC. Can you see? Vertex B lies outside the circle and its sides, can you see? They intercept two different arcs of the same circle. They intercept arc KXC, they intercept arc PYQ. You can see here, got it? Can you see this condition? Then immediately this formula should come to your mind. Measure of this angle is half the difference of the intercepted arcs. Measure of the angle is half the difference of the measures of intercepted arcs. Difference of the measures of intercepted arc. Difference of the measures of intercepted arc. Difference of the measures of intercepted arc. That means if you ask me, children, this angle ABC, okay, is half, okay, then which is a bigger arc, children? AXC, measure of arc AX, minus what's a smaller arc PYQ, measure of arc PYQ. This is what the formula is. That is what the theorem says. The moment you see like this, angle ABC, okay, vertex B of angle ABC lies outside the circle, and its two sides intercept two different arcs of the same circle, arc AXC and arc PYQ of the same circle. They are, okay, these angles are intercepting these arcs. So naturally, angle ABC is half the bigger arc minus smaller arc. Suppose I want you to prove this, okay? Prove this, okay? The question is prove this, okay? This figure is given, you have to prove it. So simple this is, children. Just try to understand. If you put the things in your place, suppose the last line of this proof should be angle ABC should be, please have a look here, angle ABC should be half measure of AXC minus measure of PYQ. That means the second last line must have been ABC equal half measure of AXC minus half measure of PYQ. So half has come out common. But half measure of our KXC, that is possible only if I use inscribed angle theorem. So see here, children, don't you realize either I join P to C or Q to A. I can join any one of them, either dotted line. Okay, Q to A or P to C. I just join construction. Draw segment QA. Draw segment QA. Now, why did I draw segment QA, children? So you can see here, children, your angle AQC is half arc AXC. You want half arc AXC. And your angle BAQ, instead of saying PAQ, I say BAQ. BAQ is half arc PYQ, inscribed angle theorem. So I got half the arcs. Now look, but I want angle ABC. What is the relation between these three angles? You can see here, AQC, BAP, ABQ. What is the relation between these three angles? H triangle is equal to sum of the remote interior angle AQC equal angle BAQ plus ABQ. But I want ABQ alone. ABQ will be AQC minus BAQ. In place of these angles, I can put half the arcs and I'll get my answer. I'll just show it to you, children. Very simple, okay? Proof. Just have a look here, children. You want to get half arc AXC. So don't you agree? Angle AQC is half measure of arc AXC. Can I call it statement number one? By inscribed angle theorem is going to be the reason. Then I want half arc PYQ also. How to get it? Angle PAQ. Just have a look at angle PAQ. PAQ equal half measure of arc PYQ. Don't you agree, children? I get half this arcs. Okay, this two I wanted. So I just showed by inscribed angle theorem. Only if I use inscribed angle theorem, I can get it. And that was the reason why I constructed that inscribed angle theorem. Okay, children? Now you can see here. But these three angles, okay, this angle AQC is half arc AX, agreed. Angle BAQ is half arc PYQ. But I want angle ABC, that is ABQ. How are these three angles related? So one good look, you can see angle AQC is exterior angle of triangle ABQ. So whenever you see an extra angle, in 9th standard you learn, extra angle is equal to sum of the remote interior angles. Angle AQC equal angle ABC plus angle BAQ. I can call it as remote interior angles theorem. Remote interior angles theorem. Remote interior angles theorem. Remote interior angles theorem. Now what will happen, children? You can see here, children, in place of AQC, it is I want ABC alone. I want ABC alone in my answer. तो इसको ये साइड लेके जाऊंगा तो एबीसी अकेला मांगता है ना तो एबीसी अकेला रहूंगा तो बी ए क्यू को उसे लेके जाऊंगा तो क्या आएगा माइनस हो जाएगा मतलब ए क्यू सी minus angle BAQ. I call this as statement number 3. Therefore, okay, now what I can do, in place of AQC, I'm going to substitute this value of AQC. Can you see what is AQC equal, children? What is AQC equal? You can see this AQC. What is it equal to? Half measure of KXC. So angle ABC equal half measure of AXC minus sign is there. And what is angle BAQ equal, children? You can see angle BAQ. This box में rectangular box में that is nothing but BAQ is nothing but you can see here, children. BAQ is half measure of PYQ, half measure of R PYQ. Can you see? I just put this reason from 1, 2 and 3. Okay, I think half common आ गया तो मेरे को आंसर आ गया angle ABC equal half. Okay, what is that? Measure arc AXC, half common. Measure arc AXC minus measure arc PYQ. Measure of arc PYQ. I think I got this, children. So remember, children, given an angle whose vertex lies outside the circle, its sides intercept two different arcs of the same circle. The measure of that angle is half the difference of the arcs, half the bigger arc minus smaller. I proved it also. I'm sure, children, everybody has understood it. Okay, we go to the next one now. Look at angle CQB. Angle CQB. The vertex of angle CQB is Q. It lies inside a circle. And this angle CQB also has a vertically opposite angle, AQD. Now, this angle CQB intercepts arc CB, brown arc. Its vertically opposite angle AQD intercepts arc KD. ये दोनों एंगल इक्वल है तो इधर CQB के देखो या AQD को देखो either way angle CQB को देख रहा हूं मैं so this angle CQB, please have a look here. This angle CQB, got it? It has a vertical opposite angle AQD. This angle CQB intercepts arc CB and this angle AQD intercepts arc AD. So measure angle CQB equal half, got it? Measure of arc CB, arc intercepted by the angle, and the arc intercepted by this vertical opposite angle, that is a half measure arc AD. So remember this formula, children, okay? Right. Given an angle whose vertex lies inside a circle, it has a vertical opposite angle. Then angle CQB is half arc CB plus arc AD. Half the sum of the arcs intercepted by the angle and its vertical opposite angle. This formula should come to your mind. Then first thing, ask you to prove it. Are you getting me, children? Prove that, okay? So let's see the proof, okay, children? Now, please pay attention here. What should be the last line? Angle CQB equal half measure arc CB plus measure arc AD. But second last line will be CQB equal half measure arc CB plus half measure arc AD. But the last line में half common आता है. So how to get half arc CB? How to get half arc CB? Inscribed angles help you to get half the arc, okay? So what I do, I just join D to B, just here. I just do a construction here. I just do a construction, children. What construction did I do? Construction, I just said draw segment BD. Construction, draw segment BD. Okay, draw segment BD. Now see the proof for it. Very simple, very easy. Got it? I want half arc CB. How can I get it? So look at angle CDB. Can you see CDB is an inscribed angle? This CDB, I'm so sorry, children. This angle CDB. Okay, this angle CDB. Can you see this angle CDB, children? This angle CDB is an inscribed angle. What is angle CDB equal, children? Don't you agree? It will help you to get half arc CB. Half measure arc CB. It will help you to get half measure of arc CB. It will help you to get half measure arc CB. I call this as 1, and the reason for it, I say by inscribed angle theorem. By inscribed angle theorem. By inscribed angle theorem. Now listen, I've got half arc CB. How to get half arc AD? Look at this angle, children, ABD. Don't you agree this ABD is an inscribed angle, children? ABD. This angle ABD is an inscribed angle, children. Angle ABD equal half measure arc. Naturally, I can say AD by inscribed angle theorem. By inscribed angle theorem. By inscribed angle theorem. But which angle I want in my answer? I want angle CQB. So what is the relation of CQB with these two angles? CQB is an exterior angle of CQB is an exterior angle of triangle. कौन सा triangle children? QDB. You can see here angle QDB. CQB is an exterior angle of triangle QDB. So angle CQB equal angle QDB. QDB can be written as CDB. No problem, okay? And plus angle CQB equal angle QDB plus QBD. QBD can be written as ABD. Angle ABD. And the reason is by remote, step number 3, by remote interior angle theorem. Remote interior angle theorem. By remote interior angle theorem. By remote interior angle theorem. So now you can see, children, in place of CDB, what you can do, you can always put half arc CB. And in place of angle ABD, children, just have a look at ABD. What you can do, children, in place of ABD, I can put a half arc AD. So what will happen, children? Angle CQB equal, okay, half measure arc CB plus half measure arc AD, children. The reason is from 1, 2, and 3. From 1, 2, and 3, children. Now what will happen? Your half is common. So I think you got your answer, what you were looking for. CQB equal half. CQB you wanted, half you wanted. And what will happen? Measure arc CB plus measure arc AD. A very simple proof. I'm sure, children, everybody got this, okay? Everybody got this theorem, okay? We go to the next, children, now. This theorem, children, theorem of angle between tangent and secant. It was earlier called tangent secant theorem. Like in now, in your new book, okay? It was earlier called tangent secant theorem for many, 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 many years. Like when I started studying, I'll say from my school time till today, till this book got printed, okay, we should call them as tangent secant theorem. But this book has given the name as between theorem of angle between tangent and secant. Theorem of angle between tangent and secant. So like the name, okay, you can see here, if an angle has its vertex on the circle, let's see one angle has its vertex on the circle and vertex B on the circle. And one side is a tangent. One side is a tangential. And one side of this angle is a tangent. You can see it, sorry. Okay. One side is a tangent. Okay. One side is a tangent. And the other side intersects the circle at one more point. The other side, when I try to draw, it intersects the circle at one more point. You can see here. It intersects the circle at one more point. It intersects the circle at one more point. You can see it intersects the circle at one more point. So you can see this angle ABC, vertex B lies on the circle, side BC is a tangent, side BA, it intersects the circle at one more point A. So measure of such an angle is always half the intercepted arc. Measure of such an angle ABC is half measure of arc AXB. This theorem is called theorem of angle between tangent and secant. Theorem of angle between tangent and secant. I hope people have understood me here. See, vertex B of angle ABC lies on the circle. Side BC क्या है? Tangent है. Side B और एक point में intersect करता है. So this angle ABC is half the intercepted arc AXB. Are you getting me here? This theorem is called theorem of angle between a tangent and a secant. Okay, children. Now we go to the next. इसका proof कभी नहीं आएगा. Okay, क्योंकि तीन cases में है. Okay, we go to the next one, children. Now look at this angle, okay? Angle ABC. Its vertex, side BC is tangent, okay? And then from B, a chord has been drawn. From the point of contact, a chord has been drawn. So can I call this angle as an angle between a tangent and a chord drawn from the point of contact? There's an angle between a tangent and a chord drawn from the point of contact, okay? And you can see it. This angle is intercepting this arc AXB. Now look at this inscribed angle. ADB is an inscribed angle. Don't you agree it's inscribed in arc ADB? This arc ADB is nothing but opposite to arc AXB. It is opposite to arc AXB. Arc ADB is opposite to the arc intercepted by this angle ABC. Okay. So now I can say like this, children. The angle between a tangent and a chord drawn from the point of contact, Can you see here? Angle between a tangent and a chord drawn from the point of contact is congruent to the angle inscribed in the arc. You can see here is inscribed in the arc opposite to the arc intercepted by the angle. Got it? By the angle. Very clear. See, this angle ABC is an angle, okay? Side BC is a tangent and BA is a chord. It is intercepting which arc? Arc AXB. Now, which is the arc opposite to arc AXB? Arc ADB. Which angle is inscribed in it? ADB. So this angle ABC and ADB are always congruent, okay? And also you can see here, children, if you see angle ABC is half measure arc AXB, I can always say like this, children, by theorem of angle between tangent and the secant. Okay, an angle ADB, when you look at it, is an inscribed angle. It is always half measure of arc AXB. You can see this, children. Suppose if I call this as 1, if I call this as 2, okay, the inscribed angle theorem, I just write the reason down by inscribed angle theorem. Now look at 1 and 2, children. Don't you agree? Right hand side half measure arc AXB, half measure. So I can say angle ABC is congruent to angle ADB. So that is what? Angle ABC is the angle between a tangent and a chord. It is intercepting arc. It is intercepting the arc AXB. Now angle ADB is an inscribed angle inscribed in an arc opposite to the arc intercepted by this angle ABC. So this angle ABC is congruent to angle ADB. We call it angles in alternate segment. Okay, children. Now we go to the next theorem, children. We go to the next